Hey guys, a very good day to you all. In this video, we are going to understand what is maximum work. In other words, in this video, we are going to understand how we can maximize the work. Now, in the previous video, we have already seen what is the meaning of work in thermodynamics. Now, if you all do not know what is work in thermodynamics, then don't worry guys. I have already uploaded a separate video on it. You can find the link of that video in the description box below, or you can simply click on this I button which is present on the right top corner of your screen. Okay, so now before moving on to maximum work, let us understand some basic concepts. Okay, so for that, let us consider a container, and in this container let us consider gas, and this gas is enclosed by a piston. Now we all know that gas is going to apply some pressure on this piston, and this gas is obviously going to apply a upward pressure on this piston. So we have represented the pressure applied by the gas as P of gas. Okay, now similarly the surrounding is also going to apply the pressure on the piston and will try to push the piston downwards, and the pressure applied by the surrounding we refer to as external pressure. Okay, now when the external pressure is equal to the pressure of the gas, obviously the piston is not going to move. It is going to remain stationary as it is. But let us consider a condition where the external pressure becomes greater than the pressure of the gas. Then in this scenario, since the external pressure is greater, therefore the external pressure will try to push the piston downwards. Am I right? So let's say that now the piston is moved downwards. Okay, but guys, when this piston was moving downwards, what was happening is that the volume of the gas was decreasing, and if the volume of the gas decreases, then obviously the pressure of the gas will increase. So as you move the piston down, it will reach a certain stage where the external pressure becomes equal to the pressure of the gas, and at this stage both the pressures are become equal and opposite, and there will be no further movement of the piston. Now guys, here, because this external pressure was greater than the pressure of the gas, therefore the piston was forced to move downwards. Am I right? This external pressure forced the piston to move downwards. Am I right? This external pressure is causing the movement of the piston. Okay, therefore we refer this external pressure as driving force. Okay, because of this external pressure, this piston has moved downwards. Therefore we say that the external pressure is acting as a driving force over here. Now when the piston reaches at this stage, obviously here we know that the external pressure has become equal to the pressure of the gas. But when it was reaching till this stage, from the initial stage, initially it was at some greater height, and now it has reached over here. While that time also this pressure of the gas was trying to push the piston upwards. Am I right? Now also the pressure of the gas is trying to push the piston upwards, and because there is pressure of gas present, therefore the piston has stopped over here because both the pressures have become equal. So can I say that when the piston was moving downwards, this pressure of the gas was trying to push the piston upwards. Now since it is opposing the movement of the piston, therefore we say that the pressure of this gas is referred to as the opposing force. Okay, so guys, I hope that you have understood what is the meaning of a driving force and what is the meaning of an opposing force. These two terms are going to be very important for understanding what is maximum work. Okay, now let us move on ahead and let us consider an example of tug of war. Now I hope you all know what is tug of war. In a tug of war, what happens? At the opposite end of the rope there will be two competitors, and both of them will try to pull the rope towards themselves. Am I right? So let us say that there is a tug of war match between an elephant versus a dog. Now it is obvious guys that this elephant is going to apply a greater force, and by applying a greater force it will try to pull the rope towards itself. Am I right? See, this elephant will apply greater force as compared to the dog, and it will try to pull the piston towards himself, and because of this he is able to win the game. Okay, because of the force that he is applying, he is able to pull the rope, and because of that he is able to win the game. Therefore we say that in this case the elephant is going to apply a driving force. And see, when this elephant was pulling the rope towards itself, this dog was also trying to pull the rope towards himself. Therefore when the rope was moving towards the elephant, the dog was opposing the movement of the rope and was trying to pull the rope towards himself. Therefore we say that the dog is also applying a opposing force. Okay, now this time I am not telling you all what is driving force and opposing force. I hope that you have understood what is driving force and opposing force, but I have shown you all this example because there is some reason behind it. Okay, so just keep patience for next 2 to 3 minutes and you will get to learn something new over here. So I hope that you have understood what is driving force in this case and what is opposing force in this case. Now here, can I say that the driving force, that is nothing but the force applied by the elephant, will be very large as compared to the opposing force? Am I right? See, if you compare the force applied by the elephant and if you compare the force applied by the dog, then obviously the force applied by the elephant will be greater, very large as compared to the force applied by the dog. Okay, so in other words, in technical terms, can I say in this case the driving force will be very large as compared to the opposing force? Okay, in other words, can I say that the difference between the driving force and opposing force is large? Clear? The difference between the driving force and opposing force is large in this case. Just keep this thing in mind and let us take another example. Now here we are going to have a tug of war between an elephant versus a rhinoceros. Now this is going to be something tough battle. Am I right? Now also what we observe is that there is a tough fight between both of them, but still the elephant wins because it is able to apply that extra force and pull the rope toward itself. Therefore we say that the force applied by the elephant in this case is nothing but the driving force, and the rhinoceros was also trying to pull the rope towards himself, which is obviously in the opposite direction to that of the elephant. Therefore we say that the rhinoceros was opposing the elephant, and we say that here the force applied by the rhinoceros is the opposing force. Now guys, the twist comes over here. If you observe two examples, see, in the first example what you observed, the difference between the driving force and the opposing force was very large. Okay, but in this case, can I say that the difference between the driving force and the opposing force will be less? Because the rhinoceros is also competitive. If you think logically, see, the opposing force, compare the opposing force applied by the dog and compare the opposing force applied by the rhinoceros. Who is going to apply greater opposing force? Obviously the rhinoceros is going to apply greater opposing force and will not allow the elephant to pull the rope towards himself easily. Am I right? The elephant cannot pull the rope easily when he has a tug of war match with the rhinoceros. Okay, so here the rhinoceros is going to apply a greater opposing force. Now my one simple question to you all: if the rhinoceros is applying greater opposing force and if the dog is applying less opposing force, then to pull whom will the elephant require greater effort? Will the elephant require greater effort to pull the rhinoceros, or will the elephant require greater effort to pull the dog? obviously the elephant will require greater effort to pull the rhinoceros. And since the elephant requires greater effort in this case, therefore we say that the work done by the elephant to pull the rhinoceros will be greater as compared to the work done by the elephant to pull the dog. The elephant can easily pull the dog. It does not have to do any hard work. It can easily pull the dog. It has to apply less effort, and since it applies less effort, therefore we say that lesser work is done. Whereas in the case of rhinoceros, it has to apply greater effort. Okay, and if it applies greater effort, therefore it has to do greater work. Am I right? Now let us become more technical. Now guys, can I say that when the opposing force is more, at that time the work done will be more? Am I right? When the opposing force is more, the work done will be more. Like in this case here, the opposing force is more, therefore the elephant has to do more work. Clear? Now I am going to say this statement in other way. Listen carefully. Can I say that when the difference between the driving force and the opposing force is less, at that time the work done will be more? See, since the opposing force is more, therefore the difference between the driving force and opposing force will be less, and at that time the work done will be more. I repeat myself again. This is a very important statement, guys. When the opposing force is more and the difference between the driving force and the opposing force is less, at that time the work done will be more. Over here, the force applied, that is nothing but by the elephant, which is acting as a driving force, and the force applied by the rhinoceros, which is acting as an opposing force, the difference between both the forces is less. Whereas in this case guys, where it is gone, in case of a dog, what is happening is that here the opposing force is less, and since the opposing force is less, therefore the difference between the driving force and opposing force is more, and hence the work done is less. Clear with this? I hope guys this is very simple, and if you are still confused, don't worry, we will understand it ahead. Now guys, let us apply the same logic in the concept of maximum work. Okay, we are going to apply the same logic in thermodynamics now. Okay, so let us consider a container in which there is gas, and this gas is enclosed by a piston, and we all know that this gas is going to apply a pressure in the upward direction, and the external pressure will be acting in the downward direction. Now let us say that the external pressure is equal to the pressure of the gas. So if both the pressures are equal, then the piston is not going to move. Now what we do is that we add a 5 kg mass. Okay, so when you add a 5 kg mass on this piston, what is going to happen? Obviously the external pressure is going to increase. Am I right? And because the external pressure increases, now this external pressure will push the piston downwards. Therefore, can I say that the external pressure is a driving force over here, and the pressure of the gas is the opposing force. Now guys, when you add 5 kg mass, what happens is that, yes, your external pressure is going to increase, but guys, it is going to increase by a large quantity. Okay, now since the external pressure increases by a large quantity, so can I say that the difference between the external pressure and the pressure of the gas will also become large? Okay, so in other words, can I say the driving force, this driving force is very large as compared to the opposing force? And if the driving force is large, obviously this piston is going to move downwards. So as you can see over here, this piston was earlier at this position, but it has now moved to this position. So over here, obviously work is done, and you can obviously calculate the value of that work. But guys, our main aim is not to do only work, but our main aim is to maximize this work. So how I can maximize this work? Let's see. What we have done, we have just brought this piston from this position to this position. That's the only thing we have to do, right? Okay, so we have to just bring the piston at this position. So let us consider another case over here where we are going to maximize the work. So let us consider the gas, and let us consider our piston. Obviously again there is a pressure applied by the gas and the external pressure. Now I want to bring this piston at this position. So what I will do is that I will not directly add 5 kg. Instead, I will add 0.1 kg of mass. Okay. Now when I add 0.1 kg of mass, what is going to happen? The external pressure is going to increase. Okay. And since the external pressure increases, what will happen? Obviously, this piston will move downwards. So as you can see over here, now the piston has moved downwards. Earlier, the piston was here, shown by the red color, and now it has moved slightly downwards. Similarly, what I will do is that I will add more 0.1 kg, plus 0.1 kg, plus 0.1 kg, plus 0.1 kg, and finally, when I add 5 kg, what will happen? This piston will now reach to this level. Okay, now what is the difference between both of them? The first difference is obviously I am adding less mass over here. Now what is the advantage of adding less mass? See, when I add less mass, what happens is that the external pressure increases, but it increases by a small amount. Okay, so this external pressure here, which is acting as the driving force, will increase by a small amount. And if the external pressure increases by the small amount, then obviously guys, what is going to happen? If the external pressure increases by the small amount, the difference between the external pressure and the pressure of the gas will also be less. Am I right? When you increase the external pressure by small amount, the difference between the external pressure and the pressure of the gas will also be small. Okay, so here the external pressure is greater. Yes, it is greater than the pressure of the gas, but it is greater by a small amount. And now you can compare this to the example of an elephant and rhinoceros. Assume this external pressure as the pressure applied by the elephant, and assume this pressure of the gas as the pressure applied by the rhinoceros. So here, since the difference between the external pressure and the pressure of the gas is small, okay, here the difference between both of them is small, therefore the external pressure has to do greater work in order to push the piston downwards, because it is experiencing more amount of opposing force. Here it is experiencing more amount of opposing force. But here in this case, what happens is that when you directly add 5 kg, the external pressure increases by a very large quantity. And when the external pressure increases by a very large quantity, then the difference between the external pressure and the pressure of the gas will also be large. Like in the example of elephant and the dog, the force between the difference of force between both of them was large. And similarly here, the external pressure and the pressure of the gas, the difference between both of them is large. And since the difference between the driving force and the opposing force is large, therefore this external pressure can easily move this piston downwards and it will do less amount of work. So what we have learned up till now, that when the difference between the driving force and the opposing force is large, okay, when the difference is large, at that time the driving force can easily do the work, and since it can easily do the work, therefore less work is done. But when the difference between the driving force and the opposing force is infinitesimally small, the less is the difference between both of them, greater will be the work done. Why? Because if the difference between both of them is less, then both of them are competitive to each other, and if both of them are competitive to each other, then the driving force will experience greater amount of opposing force, and the driving force experiences greater amount of opposing force, then it has to apply more effort, and if it has to apply more effort, then more work will be done. So guys, I hope that you have understood the concept of maximum work. So here guys, there is if you want to have a maximum work, then you must have a reversible process, because in a reversible process the difference between both of them is infinitesimally small. I hope you know what is a reversible process. I have already uploaded a video on that as well. You can find the link of the playlist of complete chapter in the description box below, or you can simply click on this I button. Okay, so I have now explained you all the concept and the logic behind the maximum work, but now let us understand mathematically to how this logic is correct. You might be thinking that I am just saying anything, okay, but I will prove you all mathematically also why this is true. Okay, so what is work? We all know the formula for work is nothing but minus P into external pressure minus external pressure into change in volume. Now let us keep this formula aside for 2 minutes and let's name this to be equation number 1. Now we know that the difference between both of them is present. I mean to say that there will be some difference between the external pressure and the pressure of the gas. Obviously there will be some difference between both of them. So let's say that the difference between the pressure of the gas minus the external pressure is delta P. In this case I have assumed that the pressure of the gas is greater. Okay, so don't get confused and don't panic, just chill. Okay, so let's say that this is delta P. The difference between both of them is delta P. Okay, now what I'm going to do is that I am going to shift this delta P to this side and this external pressure to the right hand side. So from here I get the formula for external pressure, that is nothing but pressure of the gas minus the difference between both of them, which is represented by delta P. Now just use this relation, use the formula of external pressure and substitute in this equation. Okay, so can I say that now here the work becomes minus of pressure of a gas minus change in between both of them. Now have a look at this bracket, this green color statement, this green color two words. Have a look at them. See guys, now what I was saying earlier is that when the difference between both of them is less, at that time the work done will be maximum. Okay, so let's prove that. Okay, so let us take an example and let's say that the pressure of the gas is 5 pascals. Okay, and let's say that the difference between both of them is 3 pascals. And if the difference between both of them, that is nothing but the pressure of the gas and the exerted external pressure is 3 pascals, at that time can I say that the value of this bracket will be pressure of a gas minus the difference between them, which is equals to 2 pascals. So in this case the difference is 3. There at that time we are getting 2 pascals as the value of this bracket. Okay, now let us take another example where the difference between both of them is 0.1 pressure. So here the difference between the external pressure and the pressure of the gas is less, and since the difference is less, then you can clearly see we are getting the value of this green color bracket as 4.9. So obviously when you multiply 4.9 with delta V, you will get greater magnitude of work. Do not bother about this sign. This sign only tells you whether the work is done on the system or by the system. Focus on the magnitude. When you multiply 4.9, you will get greater value of work as compared to 2. When you multiply 2, you will obviously get less amount of work. So that is what I was saying, that when the difference between both the pressure, that is nothing but the pressure exerted by the the difference between the external pressure and the pressure of the gas is very small, at that time the work done will be maximum. This is what I was trying to tell you all from so long. I hope this is clear, guys. Now guys, let us understand the expression for maximum work. That is nothing but the formula with the help of which you will be able to easily solve the numericals. So for that, let us understand one diagram. I hope you will easily understand this diagram after just having a look at it. Okay, so have a look at it for 2 minutes. By then, let me take a sip of water. Okay, so guys, what you have understood from this? So this is your step number 1, in which the volume of the gas is, let's say, V1. Now these blocks are nothing but the blocks of the mass. Okay, these blocks obviously carry some mass. Now what you have done is that you have removed one block from here, and when you remove one block, the mass on the piston decreases, and when the mass on the piston decreases, obviously what is going to happen? The external pressure will decrease, and if the external pressure decreases, then the piston moves upward, because now the pressure of the gas will be greater as compared to the external pressure. Now here you have not removed the whole mass, you have removed mass by a very small quantity. And why you are doing it? Why you are removing it by a small quantity? Because you want to do maximum work. Okay, so when you remove this small amount of mass, the change in volume is very less. Can you see over here? This is very small change in volume is observed. Similarly, what you will do is that you will remove one more mass, and now when you remove one more mass, again the change in volume that you see is very less. So what this figure shows is that when you remove small amount of mass, at that time you decrease the external pressure by a small quantity, and when you decrease the external pressure by a small quantity, then the change in volume or the increase in volume of the gas is also small. So if you remove small mass, small pressure is decreased, small pressure is decreased, then small amount of volume will increase. Clear with this? So everything is small in this case is what is this figure trying to show us, and this way you can continue so that you get the maximum work rather than just simply removing all of this. So now let us derive the formula. So let's say we all know that work is nothing but minus of external pressure into change in volume. Now in this case, can I say that since the change in volume is very small, which we represent it as dV, differential V, okay, in this case where this change in volume is small, very small, therefore we represent it as dV, differentiation 1. This is the concept of differentiation, dV. Okay, by very small quantity we represent it as dV, and since the change in volume is small, therefore obviously the work done will also be small. Clear with this? Now let us name this to be equation number 1 and keep it aside for next 1 minute. Now we know that the difference between the pressure of the gas and the external pressure is very small. As you can see over here, although the external pressure is decreasing, but it is decreasing by a very small quantity. Therefore we even represent that the change in the pressure, the difference between both the pressures is very small. Therefore we represent it as dV. P. Clear with this? Now from here I can easily find the formula for P external, that is nothing but the pressure of the gas minus dP. Now we know one thing, guys, that by substituting this formula, that is nothing but the state formula for P external. What is the formula of P external? Pressure of a gas minus dP. So just substitute this in equation, this yellow color equation number 1. After substituting the value of P external in this equation, you get something like this. See, we have just substituted the formula of P external in this case. Now just simply multiply the brackets. Now when we multiply the brackets, we take dV inside. Okay. Now what happens here is that, guys, this dP into dV. Okay. See this dP into dV is a very small quantity. This is a very small amount, because here the pressure is also very small and the volume is also very small. So obviously the product that we get will also be a small. So we just neglect it. But we cannot neglect this, because here the pressure of the gas is a big quantity. Okay. Now moving on, just neglecting this, and we are left with minus of pressure of gas into dV. Now this is for a small amount of work that is done. When you remove one block, you get small amount of work done, and this is formula for that. But we want the complete work done. Therefore you obviously need to integrate. And now when you integrate on both the sides, this D is going to get removed. Okay. So this integration of D into V, that is nothing from initial to final condition, and here the change in volume will be from V1 to V2, from initial volume to the final volume. When you increase small volume, small volume, you finally reach to one volume, which we call it as V2. Okay. So the volume will be from V1 to V2, and this P dV, this P pressure of a gas, I just represented it as normal P. Clear? Now as I mentioned earlier, this D and integration will get cancelled out, and you are left with maximum work. It will be nothing but equals to integration of P into dV from V1 to V2. Now over here you have to recollect one formula of pressure, which we call it as a gas equation. That is nothing but PV is equals to nRT. And from here we easily find out the value of P. The pressure is nothing but nRT upon V. Now just substitute the formula of pressure in this equation. After this we find out that W max is equals to V1 to V2 nRT upon V into dV. Now guys, you are going to integrate this whole thing with respect to V. Can you see over here? dV. You are integrating this whole thing with respect to V. Therefore only V is going to be variable, rest all, that is nothing but nRT, will be constant. So let us take this nRT out of the integration sign. When you take this nRT out of the integration sign, you are left with 1 upon V from V1 to Vt. Integration of 1 upon V from V1 to V2. Okay. Now just do the integration. What is the integration of 1 upon x? That is nothing but log of x. So similarly here, the integration of 1 upon V will be nothing but log of V. And this will be from V1 to V2. Do not forget to add the limits. Okay. Now here, instead of V, I will substitute V1 and V2. So here, since V2 is the upper limit, therefore it will be log of V2 minus log of V1. Okay. This is the formula of maximum work that we get. But guys, here we are having log to the base E, and we cannot solve from log to the base E when you are in 11th and 12th, because in your log book all the values are with respect to log to the base 10. Okay, so instead of log to the base E, you want log to the base 10 now. So for that you have to okay, what is this? Yeah, so before that they have just simplified. This is a baby step. See, we all know log of A minus log of B. So log of A minus log of B can be written as log of A upon B. So this is what they have done, log of V2 upon log V1. Okay, so now this is in log of E form, but you want log to the base 10, so you have to multiply by 2.303. Okay, so when you multiply by 2.303, this is the final formula of maximum work that you will be seeing in your textbook, and this is going to be very important for solving the numericals. Okay, so whenever they ask about maximum work, you have to use this formula. You cannot use the formula of PdV. Okay, that one is for the normal work that we do. I hope you have now understood what is the meaning of maximum work and what normal work I am referring to. Okay, now this is in terms of volume, but I want in terms of pressure. So what we will do is that we know that at constant temperature, this is the equation that we get, P1 V1 is equals to P2 V2. So just shift this V1 to the right hand side and P2 to the left hand side. So finally you will end up with P1 upon P2 is equals to V2 upon V1. So now instead of V2 upon V1, can I substitute P1 upon P2 in this formula? See, instead of V2 upon V1, I will substitute P1 upon P2. Okay, so by just substituting this, you get another formula for the W max in terms of pressure, and this formula you can use if you know the pressure and if you do not know the volume. Okay, so I hope guys these things are clear for you, and yeah, here you can substitute pressure instead of volume at constant temperature, because usually when you do maximum work your temperature will be constant. Okay, so this is all what about maximum work. I hope guys you have liked this video, and if you like this video then please do not forget to subscribe to the channel and go check out my channel where I uploaded physics and chemistry videos. They might be helpful for you all. And guys, thank you for watching this video.